So it's really been a pleasure to work with Weisong over the past couple of years. It's very clear that CIS is on a roll, and using vehicle terms, you're firing on all cylinders, right? So in terms of research, education, activities, it's clear that computer science is definitely on a dramatic upward exponential trajectory. Now, though, apart from my administrative roles, I'm very pleased to be able to hear about the wonderful research you've been doing in your lab, which I haven't had the opportunity to really listen to. So really, what I thought your research was about was actually in the life sciences, because whenever I see him, he's always somewhere else. So I really think he's perfected the art of cloning. Or he was in quantum, because he really is in two places at once almost every time I have seen him. So he leads the Connected and Autonomous Research Laboratory, or CAR Lab, and has quickly become a leading expert in building safe, real-time, energy-efficient computing systems for autonomous driving. He and his lab have contributed to several technologies, including Hydra One, an open-sourced experimental platform for research and education on autonomous driving, the Equinox platform for studying the co-optimization of computing and communication on connected autonomous vehicles, and the Open Vehicular Data Analytics platform, otherwise known as Open VDAP, which is a full-stack platform supporting connected and autonomous vehicles designed to address challenges related to deploying computation-intensive services on vehicles. So I could go on and on about his many accolades, but we would love to hear from Dr. Shi directly. So, of course, as an educator, one of the most important accomplishments, though, is he's advised 38 PhD students and 16 master's students over this career in the last 20-plus years. He's also recognized as a fellow of the Institute of Electrical and Electronics Engineers, IEEE, and a distinguished member of the Association for Computing Machinery. So with that, I would invite Dr. Shi to join me at the podium. And in recognition of the impact you've had in your field, I would like to give you this Medal of Honor as a part of your professorship, which we invite you to wear at any ceremonial events. So with that, thank you, Dr. Shi.
Thank you. All right. Well, thank you, Dean Phillips, for the very personalized and very touching introduction. Normally, if you give a talk outside, normally you provide your bio by yourself, right? Actually, I promise I didn't write any of this, so this is really appreciated. So good afternoon. Welcome. Thank you for joining today's lecture, both in person and online. So I know some of my former students couldn't join us today, so they are online. So thank you for coming. So in the next 40-ish minutes, I would like to share with you, what vehicle computing is and etc. But I want to, first admit that it's a huge honor to have this opportunity to share with you what we have done in the last decade, and more importantly, what we are working on right now and what our vision for the future. I hope by the end of today's talk, some of our new collaboration will come out from this. So the title of this talk actually is the title of a book recently we published with my former student, CD. Actually, she is here. She right now is assistant professor at the College of William and Mary. So she, thank you for coming back. So this was a title of our book. So here is the outline of this talk. So what I will do is first to share with you what is vehicle computing and why do we think this is the next big thing. And then I will talk about more technological challenges and some initial solutions. So to realize this vision, there's a lot of challenges. So because, if you are working on the vehicle, autonomous vehicle every day, even we are all part of this ecosystem. So that there's many societal challenges as well. So that is not something I will, will touch today. And then in the last, I will share with you the D-Star testbed, which we have been built My group, since we joined the University of Delaware in 2 years, we have built this test bed. I want to share with you what our capability is. So here is starting with our journey. So before you walk in, if you're in person today, like Dean Phillips just mentioned, you probably already saw one of these vehicles we have. So in the state of Delaware, there are only 2 autonomous vehicles, both of them in our lab. So we named it to attribute to UD. One is called Hydra U, the other one is called Hydra D. I think the one you see outside is a Hydra U, probably. But before we dive into these challenges, so why do we need to do this autonomous driving? So if it seems like it's a very hot topic, but let's pause a little bit to ask ourselves why this is needed, right? So you can try to ask ChatGPT. So why do we care about the autonomous driving? So ChatGPT is going to answer you that among these lines, so it will be more safety because that the algorithm will not do better things. Well, sometimes they may. Then efficiency, productivity. But what I want to argue here is another angle, at least as of today, ChatGPT haven't picked it up. So this will be something we call, it's a revolutionary way of using vehicles in this century. So let me starting with this, why this is so big here. So let's take a look of, back about more than 100 years ago. So this sounds like some of you maybe recognized on this. So in 1908, when Henry Ford, when the Ford Motor Company, both him and I, we were from Michigan at that time. So that, we're not at that time, we're from Michigan. So we know that at the Henry Ford Museum, if you have been there, you have the chance to ride this Model T, which was made in 1908. So if you're looking for this from the Model T, compared with those horse-based carriage, that basically they make it more efficient. If you're looking for these answers, it's applied to here as well, right? About 100, almost many years ago, it's the same thing. It's just to replace the horse, make it more efficient, and etc. But in the last century, just like today, when you drive here, where do you park your car right now? Most of you probably pay something, and then on the street, your car basically is rest there, and also costs you a fortune because you need to pay for the parking there. Now with autonomous vehicle, things are going to change significantly. So to show you one example, that imagine that 10 years from now, if you have an autonomous vehicle, while you are sitting here, your vehicle actually outside now is doing Uber or Lyft for you, make some money for you. By the time you go home, vehicle in front of you just take you home, you make some money. This is not like a joke because it just happened a month ago. You see Tesla already launched this robot taxi. So this is coming. This era is coming actually sooner than we thought. This is the one. The difference is in the last century, basically the vehicle utilization is less than 10%. Most of our time is we drive to the work, park it there, and then we drive back home. So you pretty much like an hour out of 24. Hours during a day. But with the autonomous driving era, what happens is it will be, if you have enough power source to support this vehicle, your car can basically run in 24 hours. So that is a huge difference on the way, how this will be used. I see my colleague Jack, the chair of the CCEE is here. So there is one very interesting argument here is, do we still need a parking structure in the future? Because why do we need that? So your car actually can randomly you can go to some other places. You don't need this parking structure. So those are the many things going to change our society. So that's why I say that it's a revolutionary way is coming. It's just some of us haven't realized that. That's the one part is rely on the transportation side. There's another point here is, because of the autonomous driving, each of these vehicles need to have a lot of sensors. You don't need to read each of these sensors, but pretty much after this talk, if you're curious, you can go to outside, take a look. So those vehicles, all equipped with multiple sensors, could do in long range. For example, they can even sense in 300 meters away what's going on there. Or underneath, is there a pothole here? So those kind of things will be very easy for the future autonomous vehicle can do. So this is very different from today. for our civil engineer colleagues, we need to deploy sensors on these bridges, and we need to fix them in the future. Those probably you don't need that anymore. So that was sort of idea that the sensing capability is another revolutionary thing is coming with the vehicles. So this is also the reason why the autonomous vehicle is very expensive. For example, the vehicle outside you see, the Lincoln is a 2018 Lincoln MKZ. So the vehicle itself probably only cost $25,000. But that vehicle standing outside is cost $250,000. It's 10 times of that. So where this money goes to is all sensors, it's all go to the computing unit. So this is, I hope, some of the graduate students who are attending to this talk, you will learn from here is you can do a lot of things in this very exciting area. So this is what we are viewing in the future. The vehicle will become a mobile computing platform. So we call it augmented access. The access, we use the access here. So for example, when the vehicle now, most of them are in the trunk. So if you, after the talk, you can also take a look that the trunk have a huge, is a computing unit. Well, today it's very, very bulky, but in the future, it's going to be, once it becomes a larger volume, it could be smaller. But it's very powerful. This can do a lot of computing, much, powerful than you needed for the autonomous driving. They can do many other things for the computing side. And then they can also do communication. You can put in a small, portable 5G, for example, or 6G in the future. You put it there, then you can set up a very easy communication channels. For example, in the last month, when Hurricane Milton happened at Florida, so there's 3 million people, they lost the power, right? They don't have anything, access. So that is another possibility is you don't need to drive a car there. You can argue and say, well, we can drive a car there. No, that means it's a dangerous zone. You can send in a fleet of autonomous vehicles just to go to the zone, provide the communication, computing. But more excitingly is what I want is here. Many of us don't realize that electrical vehicle is become gradually penetration in the States, globally even bigger. So for example, take a Tesla as an example. The battery power for one of the Tesla vehicle is 75 kilowatts. So if you don't know what that means is 75 kilowatts DC can translate to 10 kilowatts of the AC, which can be used to power 10 households here. Now imagine that in the if we have 1 million electrical vehicles, the total power here is equal to 35 nuclear power plants, which Delaware have 3. One of the closest one, for those of you who drive on the Route 1, you see that Salem, right? Salem nuclear power, 1 million electrical vehicle will be like 35, not a nuclear plant. So imagine if the whole United States have 200 million vehicles. That, you can imagine that. So electrical vehicle is another purpose is actually a huge mobile energy storage. This is something people haven't really thought about that. But the good news is we are very happy to see that at the University of Delaware, one of my colleagues, that is Professor Willie Captain. So he invented this technology, V2G, in 1990s. I happened to take a photo with him last week at the UD Innovation Day. So he actually holds the patent on this. So at the UD campus today, we have 12 charging stations, allow you to sell your vehicle energy back to the grid. So that is the enabler of this technology, allow you to, allow you to do this. This is another thing is you can drive the vehicle there, starting, power, household, and etc. And then obviously on the sensing side, we all know that because sensing is already there, can help you to do some application. And the storage is another big thing. I will mention it later. So I intentionally put in this because I know some of my colleagues from civil and civil construction, environmental engineer colleagues will be here. I use one as an example to show you how the vehicle can help for example, infrastructure health management. Traditionally, what you do, you deploy the sensors as I mentioned before. But now, what you can do is you don't need to deploy anything here. Each of this vehicle is a mobile sensor. While they are driving through this They will be sensing based on the vibration. They can sensing the results back to the edge server, which is deployed as cellular tower. They can detect the potholes. They can detect the bridge vibration. They can do many things. For example, traffic monitoring. So that was one of the idea. We think that it can be very useful even for the other engineering disciplines. So, but we know that I'm a faculty in the computer science, so we need to drill back to what does computer science, what are we doing here? So this is one of the things we are arguing, that this is a completely new vehicle computing paradigm is coming. If you're looking for traditionally, what happened is, traditionally vehicle, when we were in Michigan for more than 20 years, you see that it's a closed loop. Basically, it's the sensors and the data and the control together, and then you control the vehicle. That pretty much is a traditional vehicle. Today, if you're looking for in the future, the vehicle we draw this here is you have your sensors and you get the data from infrastructure, and sending here as a data plan, the control plan is not necessarily tightly coupled. They are separated because some of this data eventually going to go to the third-party applications. For example, any of you can develop an application for a vehicle, download it for your vehicle, then they can do their own. For example, battery health status, checking, and etc. You don't need to rely on what the OEM, the manufacturer provided. Very similar to today's phones. For the young generations, they rarely use their own camera. They're always using Instagram, TikTok, right? So the reason is very simple, because you can download, there are much more functions allow you to do the things. Similarly, you probably getting a vehicle, but you download the third-party application, and then they can run this very interesting application on your vehicle. So that is a very exciting field is coming. I still remember in 2018 when I gave a talk at GM, nobody even buy this idea. They said, what you are saying is, because their mindset is still here. But today, if you're looking for all the OEMs, the manufacturers, they are open to this. Even have people believe that maybe eventually one company is going to dominate the whole world. They're going to provide a middleware so that all others can just write an application on top of it. So that is something we are very excited about this. And this is a figure we're showing that if you agree with me, this is something revolutionary is coming, then what are the business model in the future? So that is something that we want to talk a little bit about this. In the future, if I go to extreme cases, you're going to get a vehicle almost for free. You don't need to pay money for that, because the company is not going to rely on the hardware to make money. Instead, let's say GM, Toyota, what they're going to do is they give you a vehicle for free. I hope that day will come, or very, very minimum cost. And then you deploy all these type of applications here. And then those service customer, for example, they're going to collect an HD map. These companies need HD map to run the autonomous driving. So you collecting the data for them, then they pay you money. So once they pay you, and then that along the lines, service provider, those companies, they're going to take a portion. And then you go to this, channel companies, I call it the channel for like AT&T, they will take a portion of that. And then the OEMs, those manufacturers, they're going to take a portion. Eventually, if you're lucky, you probably can even make money. That was exactly the same idea like today you go to Airbnb or the, Uber, Lyft. So that was probably going to be completely different way how this the autonomous, the vehicle auto industry is a new business model. So I hope by this time you probably sort of agree with me that sounds like some exciting things is coming. So now let's move on to the next one. So we need to talk about, this is a vision, right? So it's not going to happen tomorrow. There's a lot of challenges. So next, I want to spend some time here to talk about the technological challenges and some of the solutions so my group has been working on. So before we dive into that, I want to show you that what are the key technologies in one autonomous vehicle. So in case that some of you are looking for the new research topics, so this could be potentially. So this is a platform we from the 3D put it in the 2D style. So this is from the vehicle we used to have. And you can see that you have different type of things. The first one is the sensors. So if you come from ECE, for example, you work on the sensing technologies, then this is a global time. It's a very important time. Give you an example. For many of the autonomous trucking companies, they want a sensor can sense about half a mile away, what's going on there. Today, most of the sensors cannot do that. Because for the trucks on the highway, if they cannot detect as early as possible, it's very dangerous for them. So that was one of them. So you see Elon Musk's, the Tesla is pure camera-based, but we still have people is doing pure LiDAR-based. We also have people running with the newest radar-based technology. So there's no fix at this point. So you can do all kinds of interesting research here. The second one is training data. Some of you probably read the news. Okay, this particular company have this, AI today is very popular. So the more data I have, then probably I can train better models, so my vehicle is more safer on the road. So that was the common, a perception about autonomous driving. So who have the data? Tesla today have about 500,000 drivers is using FSD. So those data can help them to obviously can train a very nice, the model for them. That's why many people actually believe that today on the highway driving, autonomous driving is much better than human beings now. So if you have a Tesla, you have a FSD, you probably want to turn on your FSD that in the highway. It's going to be enjoyable. That's just one. And then there's a lot of applications here. So some of you, we already if you have a newest model, not even autonomous vehicle, you probably seen this. For example, adaptive cruise control. Adaptive cruise control is one of the very lower level autonomous technology, right? You set up the speed limit, let's say 70, and then if the vehicle in front of you is go fast, they were not going to go to past that 70. But if they slow down, your vehicle will be automatically slowed down. So that was one of them. The other thing is lane keeping. So I heard some of the friends it was not feel comfortable because when your car was a little towards on this side, the steering wheel starting shaky. Human need some time. That's why there's a very interesting thing is the psychological reaction of this technology is another thing that we need to spending time there, to deal with. But you can do segmentation. Those are basically if you're working on computer vision, image processing, that's the field. And then computer hardware. So that, as you can see that, NVIDIA, ARM, Intel, all of this kind of, the traditional CPU or GPU makers, now they are diving into this because each of the vehicle needed this type of computing power so people can work on, hardwares. And then storage system. This is an interesting area. Not too many people are starting working on this, but imagine that one of the autonomous vehicles each day going to generate depends. Using our vehicle is 14 terabytes of data each day. So how are you going to be store this data? And more importantly, how are you going to be process this data in an efficient way is another big challenge. So I'm going to mention a little bit later what we have done this. Real-time operating system, because in our smartphone or in our desktop, if there's something wrong, you can reboot it very easily. But right, even if you have a little bit delay, it's fine. But imagine that you are driving a vehicle on the highway now. They said, something wrong. Let's reboot the whole thing. That's going to be a disaster. So real-time operating system before was not, people are doing the research, but it's not really reaching to a point that is ready for the autonomous vehicle. So this is still an ongoing topic. So and then middleware on top of the real-time operating system. On top of that, we call the middleware. That is allow you to write in the code, for example, for the system and etc. That's another challenge. And then communication. This goes back to for the colleagues in the EE. So communication is a big deal. Many of the autonomous vehicles today is not rely on communication. It's because they are not reliable and the unpredictable behavior makes it very dangerous. Last thing, but obviously the most important is the next thing it will be coming is the more sensors, the more computing you put it here, it's more insecure of your vehicle. Imagine if you have a vehicle is parking there, somebody else is driving them around. That's going to be quite a surprise to you. So the security privacy is a very important issue that fortunately, UD, we also have a big, just getting a CCAP center, it is a very important topic. So that's just give you a very generic, we haven't talked about what we have done. So the key point here is vehicle computing vision, you need autonomous driving. But autonomous driving itself is very hard. So you can see all this news, basically is all this accident, is happening in the system. There are two types of big challenges if you ask me to high level. The one is the scale of the data that the autonomous vehicle is having. Huge amount of data. This was an older one. It's 2017. Intel estimated 4 gigabytes. Today, easily goes to 14 to 30 terabytes of data each day. You need to process them. And then the other thing is you have very complex environment. Just now before the talk, we talked about when Stephanie was here, she came from Arizona before. In Phoenix, California, you see a lot of Waymo, cruise automation is doing there. So why not they're doing in Michigan? Obviously, it's because in Michigan, what happens is those are the common weather there. So autonomous vehicle not going to be behavior nicely in this scenario. So, but you don't want to have a vehicle, every time when there's a snow, okay, today we should park here. We're not going to go anywhere, right? So that was another very big challenge, that faced by the autonomous, vehicle. Even today, it's still a challenge. So I sort of identify 5 challenges that in this area. The first one, obviously, is the computational latency, because you need to process this application, the object detection algorithm, or some other algorithms. Today, many of the autonomous vehicles have more than 50 machine learning models running at the same time in a real autonomous vehicle. So if you have more than 50 machine learning models running at the same time, how can you guarantee that this can be done in a layperson's way is fast enough, right? But fast enough is not a computer science jargon, by the way. If you're using fast enough in defense, you will be failed. I have to remind you. You have to using the professional word to talk about this. For example, hard real time means it's predictable. For example, you need to detect these people, the vehicle in front of you, within 200 milliseconds. If you less than that, it's useless because your car is already hit that particular object. So that was the computational latency we needed to deal with. Because of the data and etc. I'm trying to show you that this is very important. The challenges that are faced by the community. So basically, what you're going to do is you're trying your best to accelerate the inference. You can design the new hardware using or given the existing hardware, but you are doing some quantization, some other branch. Some of you working in this field, you might know that. So one of my students, what we have done in this is. What we did is we call the profit published 2 years ago is if I know one particular frame, when I see it, first when I see this frame, I know that it's too late if I make a decision because you can sort of in the deep learning models, you can see multiple layers. You can see the easy to understanding is if you know that if I process this frame, it's too late. Even you get the results, but it's too late for you to make the decision. You should throw this frame away. Actually, that's a very simple idea, but when you implement it, you find that it's very efficient. To give you an easy way is, normally this camera is 35 frames per second. But if you want to do all this processing, probably 5 frames per second is good enough. You can make but you need to smartly choosing which frame you want to process. So that was just one of the ideas. The second challenge is transmission cost. Many of the people in the academia, we don't consider that. Cost, that's not good. We like to make an impact of the work. We don't care about the money, right? But this actually is a big deal because earlier days, if you think about that, when you want to collecting this data, shipping to the data center, and then you can do the process. For example, at Ford, they have a division called the GDIA, Global Data Insight Division, something like that. So that group have 1,000 people. So what they do is they're collecting all the data sitting in the center, and then they do the analysis. But they all do this offline. So now today, if we are allowed with connected vehicles, you actually can start in real time moving this data back to the center, to the real-time analysis, so you can know, there is a car, something is wrong with my engine, and etc., right? But this is not free. So what happens is, doing a quick calculation here is the cost of data transmission for example, Toyota alone have 10 million vehicles globally. They're going to need to send in 20 petabytes. If you don't know what the P means, if you know the terabytes, or if you know the gigabytes, it's I'm lost. So if you have terabytes, so that will be 1,000 terabytes. If you're using gigabytes, it's 1 million gigabytes. So that is what they're talking about. The cost alone, just collecting this data, is going to cost $1 billion for them. So who's going to pay for this? I mean, auto industry, they can't afford this. That is why you need a new technology to handle this. Although, sounds like it's great, right? But it's not easy for we to deploy this. So the key technology here is the one we now today, many people are already aware of that. It's called edge computing. But I want to spending a little bit of time on that is because, in the edge computing, which is what we have done in the last decade. So I actually showed these slides during my interview 2.5 years ago. I don't know when do you remember that, also at this stage. So now let's dive back a little bit about 10 years ago, 2014. At that time, cloud computing was just starting blossom. So I was at NSF. At that time, we were thinking about what's the next thing, right? So that if cloud is already been there for 10 years, in the cloud computing era, what happened is the key features here is let's using we sometimes using 3V or 5Vs to characterize the data behavior. For example, you have a variety of data, video, audio, social media. Volume is at the PB level, and then velocity is near real time. So cloud computing, basically, the strength is you collecting all of the data, moving to the data center here, and then do the processing. One of the famous paper in that year is by Jeff Dean. Jeff Dean now is an NAE member. So although many people believe Jeff Dean now is an AI, is a big name in the AI field, but I think his classical work became an NAE member is here. Is a MapReduce in OSDI 2004. That basically is a programming model allow you to write in the code for the cloud. Without that, nobody can even touch the cloud computing at that time. So that was, I coined this digital infrastructure 1.0, the cloud. But then what happened is, sooner things is changing from 2015. If you think about it, now we are looking back, it's perfect because at that time we were predict, right? So the data generated on the edge of the network. Let's pick in this related one called, in East Asia, they don't call CAV, Connected Autonomous Vehicle. They call ICV, Intelligent Connected Vehicle, but it's the same thing. So basically, if you're looking for the data generated by the vehicle alone, contribute to 17% of the global data right now, because it's a huge amount of data is generated here. And if you're looking for more, I know, Gio look at me, are you sure? Health is also generating a lot of data. It's true. So that basically by Gartner, as of next year, 75% of the data was generated and will be stored at the edge of the network. It's not going to be moving to the cloud. Because of the privacy concerns, because of the transmission cost, they are not going to be moving to the cloud. So at that time, what kind of programming model we're going to have? So this is the idea that we come out to term this edge computing in the year 2014-15 time frame. So here is digital infrastructure 2.0. So you can see that the scale is much bigger. That the variety of the data is, now you can do very thin. For example, each of these lights going to generate the data here. So it goes to everything is here. And then volume now is goes to, much bigger at the ZB level. And then the speed is very fast. The real time allow you to do this type of computing here. So the key features here is you're going to have a huge amount of, the data distributed in the cloud, edge, and how you writing programming here. So one of the work we have been proposed is called Firework. That is one of the work come from our group, and then Cloud Native from CMU. That is another type of the research along these lines. So basically, this is a figure taken from the 2016 paper we wrote about the edge computing paradigm. So this basically explaining that is the edge computing era is coming, and then the data going to be, there's two ways. No, the one way is go to downstream from the cloud to the things. The other one is upstream, because your thing is IoT going to collecting data, sending back to the cloud. But then you do a lot of process along these lines. So this was the original figure we wrote in the 2016 paper. And then as of today, when we do faculty interviews, when you run into some junior faculty members, you ask them, what are you working on? They will be very proud to say that I'm working on edge computing as one of the research areas. And the people already realize that the edge computing pretty much is a 3-tier edge computing model. Microsoft in 2017 already Satya claimed that Microsoft is an intelligent edge computing company. That is what he's in his talk. So basically, it's cloud, edge, and IoT. Pretty much most of this, if you want to write in a code, for example, in the health, in the auto industry, manufacture, many of them actually follow this model. So next slide, I want to show you a little bit about, in the edge computing field that we have made some impact here. In the 2016, so I wrote a proposal to NSF to organize a grand challenge on edge computing with Professor Mu Chang. At that time, he was a professor at Princeton. Now he's a president of Purdue University right now. So that his research is also in edge computing. So we run this, and then we submit a report to NSF. After that, several agencies created many edge computing programs based on this. In the same year, actually after this conference, October 26th, and then we have this the first ACM IEEE symposium on edge computing happening in the same year. And also that in case you are interested in this paper, you can take a look of this edge computing paper we wrote we actually finished in 2015, but then as of today that, it has made some impact in the community. And then we started working on, we need to find a specific area we want to apply edge computing, which is connected autonomous vehicle. So we also wrote an article. Arguably, this was the first one, edge computing for autonomous driving in the 2019. So that actually goes to about where this today's topic. The challenge 3 is about time variations. Challenge 3 looks like I'm run out of time, but I will go a little fast. So this is one of my PhD student work. So I want to share with you that it's very interesting. What happened is today when you develop a machine learning model, you probably think, oh, I got a good accuracy, I have a good performance. But then what he found out is the same machine learning model, if you apply it in the morning, I'm a little bit exaggerate, not a scientific way, in the morning or in the afternoon or in the evening, the latency is different. This will be very dangerous because this variation, that means today if you're driving a car in Newark, you are safe. Tomorrow you drive to New York, your car will be like, so this is a variation of the machine learning models on the same vehicle will be a big problem for the auto industry. So that was his observation. And then he wrote a paper, and then we're trying to identify what are the challenges and etc. So this actually goes to writing a workshop paper because here is a tricky. If you're writing an NSF proposal, don't publish this paper as somewhere too fast. Okay, publishing a small workshop to showing them I have done some preliminary work. That's why actually this just been funded at NSF this month, so that we are in the next 3 years. This is one of the projects that we will be working on to identify where is the variation and how we deal with this variation. Next thing I want to mention is remember that we are not sitting in the office just design these machine learning models. We actually develop something for the vehicle outside. It's really on the road. So real-time deployment is a big deal. So this is something every time when I give a talk, I always try to convince some academic friends, latency is very important. If you develop an algorithm very accurate, but it takes too long, it's useless in this particular scenario. So for example, we do this evaluation for the acceleration, brake, and the steering with different type of the vehicles, and we found out that this, you need to earlier enough because the vehicle physical system needs to take time to take action. So this is another one. NSF have a new program called the Safe AI. So this is that we lucky enough. So we just getting funded. Also starting this week is a $1.5 million with my colleague Xi Peng and Chen Mo from ECE department. A Safe AI project, a 4-year project, is exactly looking for this, how the AI models apply to the real physical system. Last one I want to mention, the challenge is, as a computer science scientist, we care about how do you write in the code for these systems, right? So that Jamie just now introduced that we come out, I need to go fast. 2018, 6 years ago, we was come out the idea that eventually the vehicle should have a common infrastructure, allows anybody can write in the code. But today, it's not. For example, I show you an example. If I ask any of the students today to writing a code for autonomous parking actually is not difficult. You can easily, you see, this is in our lab. These little robots can do autonomous parking in the lab, right? So the code itself is easy, but the challenge is, do we know how to write? How do we read something from the vehicle? Because today's system is all closed. So this is something our group have spending 4 years to develop a set of, this is the first in the globally. We even trademarked this, called the Vehicle Programming Interface, VPI. Our idea is trying to push in this to be a global standard. So then the future, all the vehicles were supporting this VPI, allow the next generation of the programmers can write in code for them. So this was, I just share this. And this one right now, we just have a paper. So there is an open source called the AutoWare Foundation. It's funded us. So now my students, William, actually is leading this working group. So we are trying to put in this VPI into that open source so that globally other people can use this programming interface to run the stuff. Okay, so I think that's almost the last thing is about the storage. So I have to skip this because I run out of time. So the one thing I mentioned is the storage is a big deal. So this is a project under the NSF IUCRC umbrella and was funded by the largest storage company, West Digital. So they are also looking at, for the future autonomous vehicle, what is the storage going to look like? So this is an ongoing project. So I really want to spend maybe a few minutes here to share with you that what we have built at UD right now. So in the last 2 years, we have built quite a few that, the hardware platform, starting from earlier is for indoors, and then we started building this, outdoor, as you can see outside. We also building this open intersection and some indoor platform. I have a little bit of video to show you, but I guess for the sake of time, I'm not going to play. So this was one of them. Is a voice-controlled, autonomous robot. Now they can navigate in the indoor system. It's an ongoing project that Jamie and Mark, a couple of alums, we are working with local facilities trying to develop autonomous wheelchair. Jill was there the last time. So this was just showing you that today it can run in the internal now. And then I have the indoor test bed. And then we have this outside, the two vehicles. You can see the first time they're sitting together. So for the sake of time, I will just skip this. If you are interested, there's a video on our website. This is what I really want to show, that basically we treat the whole Star campus is our live and involving test bed. So this is the whole Star campus working with many of the, you can see the whole stack of the industry partners. So we are trying to, right now, we have some pending proposals. Is really trying to help the people who working and study in the Star campus. Right now, we have about 34 or 35 companies have more than 3,000 people daily in the Star campus. But now you only have a UD bus is only go this way. So we want to running an autonomous shuttle go from this. I hope can be funded, and then by the next year, when you go to the Star campus, you can sitting on one of the autonomous shuttle sitting there. Another thing we are also in the process to build is we will build a private 5G network for the Star campus. So this, if you're showing, this was like, we plan to put in the station here, and then it will cover pretty much. So if you are from agriculture or if from the sports complex, so all can benefit from this 5G, which allows to do many of the interesting research here. So I want to mention that. And then there's, I already touched about this. So those are the ongoing funded activities that we have been doing right now. So before I joined here, we spent 2 years at Wayne State to secure an NSF IUCRC center. But by the time it's funded, I moved here. So now that center is stayed at Wayne State. So I'm on the consulting role for that for the center. But we still, as a UD, as affiliated the university, like storage, the project will still going through that. And then since we come here now, we have doing several things. I want to mention this was funded just last week. We are one of the 8 centers funded by NSA. This is what they call the National Centers for Academic Excellence in the cybersecurity in general, but with specifically focus on the workforce for the next generation of the automotive industry. So this was teamed up with Auckland University, University of Michigan, Dearborn, $3.5 million just funded last week. So that was the one. We are doing, this is related to the education workforce. So I'm the person who gives the presentation here, but I know that, I want to celebrate this with all of my, the students and the postdocs. So in the last 22 years, so I have a chance to working with 40 PhD students. 28 of them already graduated. Some of them actually was here. Thank you so much for coming. So that in the green color was the one who already graduated, and right now I have 12 PhD students. That is still in the queue. I hope for some of you can find yourself. I intentionally picking these 4 pictures. Have a 5-year gap. You probably can find yourself if you are sitting here or either online. So this is the also along these years we have many of the collaborators. I couldn't list many of them, but I just list those who currently we have joined the project together, or we just submitted a proposal in the last few months. So thank you so much for the supporting. That I know this picture for you, if you don't know them, it's just a photo. But for like Mark is sitting here, he probably smiling, see himself is in this. So there is old Chinese say is actually an idiom saying that when you drink water, you need to think about its source. So for me, my academic source is come from these 3 people. So I want to spend for example, my PhD advisor, my later PhD advisor, that. I'm very fortunate to become her second last PhD student. When I graduated, she is already 77-year-old. And then I also, Professor Zvi Kidam and Vijay Karmachiti from NYU, so that during my PhD time, they are generously offered me a 2-week to visit NYU. When I was a student, they paid everything, so that it completely opened my eyes about the academic, the atmosphere in the United States. So that's actually opened my way to decide to stay here, become a faculty in the States. So that was actually my advisor for just a little to show you that she is hailed as the mother of computer science in China. So many of her students are National Academy of Sciences, Chinese Academy of Sciences, Chinese Academy of Engineering. So I also want to thank the 4 institutions which I have fortunate to working with. Thanks for them to generously invest in me, allow me to advance my career. So that some of you probably know that I spending a few years at NSF. That's last, but the most important is family's love and the support is the key. I want to I want to start with my younger daughter who is sitting here. So this was a picture we took that the day when we moved out of Michigan. So she was sacrificed a lot because she has to put in all the friends, behind. So it's I really want to thank you, Macy, so that even in the last 2 years, every summer I brought her back to Michigan to reunion with some of her friends, and then that 4 months later we have in our rental house in Wilmington we have a very lovely, everybody is happy, including this little, Wes is here. And then that my older one couldn't join us today because I don't know, she might be still, online. So she right now is studying abroad at NYU Madrid. So that last, but absolutely the most important, the person I want to thank is my wife. So I'm showing a younger picture here, is that in the last 24 years, when we moved from US to NYU, so that, without her unwavering support and enormous, sacrifices, I wouldn't be standing here. So I will give this medal to her tonight, I guess. So thank you so much. So with that, I will conclude my talk and stop here. So in case that, I know for the online live stream, you can ask questions, but in case you have any questions, sending an email to me, I will be very happy to answer. And then for those of you who are interested to explore this field, being encouraged to look at this, so we have 2 books along these lines that you can take a look. The one is specifically on autonomous driving. The other one is more general view about the vehicle computing. Thank you so much. Thank you.
So we'll take a little bit of time for questions, about another 5 or so minutes, and maybe I can kickstart with one. Thank you so much, Dr. Shi. This is a wonderful presentation.
Thank you.
Of course, with cars, autonomous vehicles, safety is critical. So could you comment on the redundancy that you have to kind of build in these systems to make sure that there's never a failure, because failure is not an option in this case, right?
Right. So actually, that's a key point. In our latest, the proposal was funded by NSF Safe AI. One of Chen Mo's work is exactly on the redundancy. We need to make sure that redundancy at multiple levels. For example, camera-based probably is not going to good. It's not going to working fine during some bad weathers, right? So in this case, you have a LiDAR or have a radar, because radar is all weather. No matter what kind of weather, they can still sensing. So at the sensing level, at the computing level, you also have the redundancy. For example, why autonomous vehicle is so expensive is basically, I want to give you an idea that any vehicle you see in the city of Phoenix or San Francisco today, the cost probably is about $1 million. The real vehicle on the street is because of the redundancy. They have to have 2 sets of the system running, so in case something wrong, the other one can pick up very quickly. That's on the computing side. So from algorithm, almost every level of this, you need redundancy. So you hit a very good point that it is the most important, as of today. Thank you. Yep, Dong. Yeah.
Thank you for the talk. You mentioned about the storage part, and just want to have more comments on that part. Do you think the capacity, the storage speed or the latency, or which part is the most important aspects in the future?
Okay, since he's using microphone, I don't need to repeat the question, right? I think. Okay, perfect. That's a perfect question. Many of the people working on storage was curious about what are the challenges in this field. I have to tell you that even this is still open. Not many people know that. From our perspective, we look at that is the programming point of view, because the data today is not just you store here. You need to make sure it can be accessed by many third-party applications so that they can access. At the same time, privacy. You're not going to impact the privacy of the data. So it is a whole system. That actually is what the West Digital is quite interesting to working with us. It is more about how to use it. So now go back. They do have some challenges though. For example, because of vehicles, when the condition is much rough, rather than you have a computer sitting here, it's a quiet condition, right? So that some of this physical environment might gonna have some big impact on the storage design. So Samsung recently just announced a new design, even including some of the redundancy. You have to be ready. Because imagine that if you're driving on the road, particularly in Michigan, we have a lot of potholes, right? So your vehicle is shaky, and then your storage, maybe a disk drive, probably what kind of medium can be used for the storage is also a challenge. But this is still an open field. Not many people actually even touch this because they haven't reached to the point that we have a large volume of the autonomous vehicle. Yes. Good. Okay.
Professor, I have a question, but it's not about doing researches. I would like to ask, if you can travel back, decades of years to the younger you when you are pursuing a PhD degree, what is the most precious experience that you would like to share with you?
Good. Boyan was my own PhD student. So he's challenging me that normally during the individual meeting, they don't ask this type of questions, right? They're always reporting, I make this progress. So you pick the right time to ask this question, right? I would say that, open-minded. So, for example, you probably know that university, college, department, we working very hard to invite a lot of people come here to give a talk. So imagine that everybody, whoever is coming here give a talk, they're spending the talk itself maybe just 1 hour. But I'm sure that they're spending tremendous amount of time to prepare for this talk. So I think listen to talk is the most important thing that for as a student is, I'm not asking you to go to every, all the talks, but the idea is open-minded. When somebody, many of the PhD students have the following, I wouldn't say the problem, but it is the habit is, I'm working on security. This guy is talking, have no relationship with what I'm doing. I'm not gonna go to attend. This actually is not good. I still remember that when I was, back to a student in the college, I remember the one day when the people ask, that every Friday evening on campus, they have some, at that time, just starting disco. I don't know, in US, but in China, some people go to dancing stuff. And then one day, I remember that is a professor, associate dean from Penn State University. So he was invited to give a talk at Xidian University. So I was there. And then he opened, after the introduction, he said, wow, look at the other side. You have see all this light is on, people are dancing, there, but you guys are sitting here, listen to my talk. So he's, at that time, we probably have a chance to see any non-Chinese speaker probably once or twice in a year. So when you open, that was one of the things I highly recommend, that even some other talks try to be there, because some of the innovation, particularly these days, that because of the multidisciplinary, interdisciplinary research. For example, earlier this year, I have a chance to heard, Professor Gerald Higginson's keynote at the Chase. Some of you probably also there, right? So the first time I see that, what? That research sounds like it's a smart connected health very well, right? So it's very important to, open-minded. If you have somebody already coming here, willing to give you a talk, so please, that's, because today I'm give a talk, I use this one. So you may have some other interesting things, but I think it's going to open your eyes. The key point is your eyes need to be opened. That's the key. Thank you. Okay.
Well, it was perfectly timed to 5 o'clock.
Okay.
And spoken, you ended on a statement that is something of a true visionary, as you said, eyes wide open. So let's thank our speaker once again for the wonderful presentation.
Thank you. Yeah, also online.